Volume number 2, our goals today. I can identify cross sections of solids and use them to determine if the volume can or cannot be determined. I can find the volume of oblique solids, and I can identify three-dimensional shapes generated by rotations of two-dimensional objects. All right, so what's a cross section? A cross section is the two-dimensional shape that you get from slicing a three-dimensional object. So if you look over here, I have a triangular prism. I slice it parallel to the base, and I get the same shape as the base. I get that triangle right there. Okay. Now, if I sliced it vertically, I would get a rectangle. Depending on the size of the rectangle would vary depending on how I sliced it. But if I sliced it, like right here, and I open it up, I would get a rectangle because you have a horizontal on the top, a horizontal on the bottom base, and then the other two verticals from the slice. A couple other shapes here. Any right prism, like all of these four over here, if you slice parallel to the base, you'll get the same shape as the base. These pyramids, this one would be a rectangle if the bottom is a rectangle or a square. And then this pyramid, you'd get a triangle if you slice that. Here's a cylinder. If you slice it parallel to the base, you get the same base right there at the circle. Perpendicular to the base, it actually ends up being a rectangle. Okay, if you think about, sawing a can of soup in half, or a wooden cylinder. Think of it as a wooden cylinder, and you open it up, it would be two rectangles there. All right, so here's a couple problems here. A right cone is pictured below. Select the type of cross-section formed when the figure is cut by a plane. A plane is a flat surface containing its altitude and perpendicular to the base. So your plane is going to be like you're sawing it in half, right, like that. So I think it's going to be a triangle when I open it up. Let's take a look at the picture here. And sure enough, there it is. So they kind of slanted it a little bit so we could get a little angle and see what it looked like. So yes, that would be a triangle. Now, if I cut it parallel to the base and open it up, it would be a circle. Okay, it'd be like, depending on the size, the higher up, if I slice it up here, it'll get smaller. Okay, and the bigger I slice it down here, the bigger my circles will be. Okay. A sphere, select the cross section when it's cut by a horizontal plane. So really, honestly, on any sphere, when you slice it, it will always be a circle. Okay, so horizontal. Obviously, the lower your slice is towards the equator, towards the center of it, the bigger it'll be. All right, and the more I cut it towards the top, the smaller it'll be. Okay. Rectangular pyramids pictured below. Select the type of cross-section formed when the figure is cut parallel to the base. Okay, so it's cut parallel to the base like that. It's going to be the same shape as the base, just getting smaller as you go up, kind of like we had with the cone. Okay, so here's a good picture there. Okay, so do your practice problems. There are plenty of these. You can do as many as you want. You have the ability to do unlimited problems. So make sure you do a bunch of these until you are getting them right consistently. All right, so an oblique solid is, it's kind of slanted now. It's not perfectly right from the ground. Your height is the perpendicular distance from base to base, perpendicular, okay, 90 degrees from base to base. So do not use this length here as the height. That is wrong, okay? Don't use those, all right? The height has to be vertical and 90 degrees from base to base, okay? So I put here the height is always perpendicular to the base, okay? Or base to base. I guess if it's a cone, if it's a slanted cone, there's no other base, but yes. So using cross sections to determine if the volume of a solid can or cannot be determined. So if all cross sections of a solid cut parallel to the base are congruent, then the volume of the solid can be determined by using volume equals base times height, where B equals area of the base and H is the perpendicular distance from base to base of the solid. So here's some examples here. So when I look at the ones on the left, these ones can be determined because all three of your two bases and your cross section, they're all congruent. Okay, so the volume can be determined because all cross sections parallel to the base necessarily have the same area or are congruent essentially. Okay, same thing here. All of these are the same exact rectangle. So you could, area of the base here. Let's do this top one. This area of the base would be 30. And your height, notice it's perpendicular. So it'd be volume, volume equals area of the base times height, so times 6. Volume equals 180 cubic units. Same thing here. Your height is perpendicular. It's not this this curved distance. That's not your height. So the area of the base here is 36. So your volume equals 36 times 12, which would give you 432. Let me just erase that. Units cubed. All right, and these ones can't be determined because this thing has, in this cross section, it's much bigger than the top and bottom. Same thing here, just opposite. This cross section is much smaller than the top or bottom area, so they're not congruent. So therefore, these cannot be determined. All right. The volume of the oblique triangular prism below. Find the volume of the oblique triangular prism below. Round your answer nearest tenth. So this is a right angle down here. They mark that. So I know it's hard to tell. It doesn't look like a right angle, but if you think three-dimensionally. So the area of the base is going to be 1/2 base of the triangle times height of the triangle. So the area of the base of the whole prism is 20. So your volume equals base times height, 20 times 10, because 10 is my perpendicular height there. So volume is 200 cubic units, okay? Did I say? Okay, yeah. All right, next one, same idea here, area of the base. So this is a cylinder, it's an oblique cylinder. Volume equals area of the base times the height. Your base is pi r squared. So pi times 4 squared, your area of your base is 16 pi. So my volume equals 16 pi, that's my B, times the height is 6. This one tells me to round, so I'm going to use the pi button. So I take 16 times pi times 6, and I get 301.6 units cubed. All right, next one. This time it's a little trickier. They don't actually give us the height. So we got to do Pythagorean's theorem to find our height. Now I know this shape here on the base. You're like, what is that? Is that a parallelogram? Is it a rectangle? They tell you it's a rectangle. It's actually a square because 11 times 11 is, or I'm sorry, 11 and 11 are the same. So we would know it's a square, but a square is also a rectangle. So shouldn't really matter. So area of the base is going to just be 11 times 11. So the area of the base is 121. Over here, I'm going to have to do Pythagorean's theorem. 7 squared plus h squared equals 12 squared. 49 plus h squared equals 144. So I end up getting 95. So my height is the square root of 95. Now I left it like that. I didn't round it because I don't like to round in an intermediate step because then my final answer is less accurate. So volume equals area of the base times the height. So I'm going to use the 121, and then I'm just going to put the square root of 95 in there. If it wanted me to leave it as an exact answer, I would, make sure no perfect squares come in there. I could actually leave it like this if I wanted it exact. It tells me to round, so I'm going to type it in. And that's what I get. All right. I get 1,179.4 cubic units. Or if I wanted it exact, I could leave it like that. Okay. Here's another one where they don't give you the height. This time they don't even give you the hypotenuse of the right triangle. So this one I'm going to have to use a sine, cosine, or tangent. So what I'll do here is I'll start out by finding the area of the base because that's real easy. It's pi r squared, pi times 5 squared. So I get 25 pi. That's easy. Now here, if this is my angle, this 50 here, this is the opposite leg, and this is the adjacent leg. So remember your SOHCAHTOA? Opposite and adjacent would be tangent. So I'm going to say tangent of 50 degrees equals the opposite leg over the adjacent. So then if I just multiply each side by 5, I get h. Now I'm going to have to round here. I guess I don't have to, but I will. I'll just round it. 5 times the tangent of 50 and I'm going to get 5 point. I'm going to take it out a little further because I have to round to the 10th. So my game plan is take it out as far as I can. 5.9588. That'll keep me closer, more accurate because I took it out way further than where I'm going to round to. So my volume equals 25 times pi times 5.9588. Or you could just leave it in your calculator. That's what I'm going to do. I'm going to leave it in my calculator right here. And that way I don't have to round at all, technically. I'm just put times 25 times pi. And I'm going to get my volume equals 468.0 cubic units. Okay, so if you get one or two like that on there, those are a little more advanced because they're applying multiple standards in one problem. All right, solids of rotation. Match the two-dimensional shaded region below to the solid form by rotating the region about the bold axes. Okay, so it's going to basically rotate around that axis. So if it's not touching here, you see how there's like a little gap here? Okay, I'll put an X there. When I rotate, it's going to sweep out a hole. You're going to end up having a hole right there. Okay, and this is slanted, so it's not going to be cylindrical. So if I'm rotating horizontally, I can eliminate these. And then actually I can eliminate all three of these. So it'll actually have to be A. But you notice here there's a hole in the middle, and you see how they put the radius of 2? That's because I have a 2-unit gap there. Okay, so the whole hole has a diameter of 4. And then this is 4 here, so 1, 2, 3, 4. So this outer ring here is also going to be matched up with that unit. And then this 2 here goes with that, okay? Same idea here, it's just not slanted on the top. So, when we rotate it along that axis, again, there's a gap here. This gap is 4 units long. I can eliminate the vertical ones, and then your hole has to be 4 units big. So I can eliminate 4 units for the radius, actually, 8 units across. So that would be B right here. And same idea up top, this is 4, so this would be 1, 2, 3, 4. And then this is 3, so that would be 3 right there. So if I use a little highlighter here to highlight this stuff here, this 4-inch gap goes with that. This 4 up top goes with that. And this length here goes with that the 3 units. Okay. All right, one more, or maybe 2 more. This time I'm rotating it this way. So again, I'll have a 1 unit hole, 1 unit radius hole. Again, get rid of the horizontal one. So this one has, both of these have a unit of a hole with a 1 unit radius. So I can get rid of that one. This is 3 units right there. So that's what I want, this one right here. Okay. And again, I can kind of match them up here. This hole of 1 matches with that. The height of 4 matches with that. And 3 right there is that outer ring. All right, last one. Now this one's on the axis, so when I rotate it, I'm not going to get a hole. So I can get rid of anything with a hole. And since this point right here stays put, it's going to basically be like a cone. It's not going to be a plateau like C is. C would be if it was like flat right there and I was rotating it. So I can get rid of that. So it's got to be this one. And again, double check your units. So this is 5. That matches with that. This is 4. That matches with that. Okay. All right. That's it for this lesson. Make sure you do your practice problems. You can do as many as you want. You have access to unlimited problems online.